In this video, we're going to cover how we do validation for user input. So what you see here is a simple program that is going to ask the user a simple question to enter in their age and then turn around and print out the age that they entered in. So anytime we're going to accept data or input from the user, we have to expect that the data may or may not be valid. Perhaps they've made an error, and we want to make sure that our programs can handle whatever the user puts in, whether it be reasonable data or invalid data. Just demonstrate kind of the problem that we're trying to solve here is that, let me go ahead and run it the first time. I'll run this program, and you'll see the screen pop up to ask the user to enter their age, and they go ahead and enter 43, click OK, and then it turns around and just prints out what value they entered in, which is great. So the program works beautifully as long as good data is entered in. However, if the user does a mistake, for example, let's say they don't enter their age, they enter in some text instead. In this case, this is not valid data. And what's going to happen is the program is not going to be able to perform this parse integer, because what it's trying to do here is take whatever the user enters in, turn around and turn into the integer equivalent of that value. And clearly this is not an integer, so it cannot be converted. If I run this program, you'll notice that I never got my prompt with what the user entered in because it failed before it got to that point. And you can kind of see down here, it's telling me that the failure occurred on line 7, which in fact is what I would expect, because that's where it was attempting to parse that string and it could not parse it into the number. This is a runtime error, and when runtime errors occur, that basically means the program has hit something that it can't handle, and the program will stop at that point, abruptly stop. So we really want our programs to be resilient. We want them to stay running, and we don't want to have runtime errors cause our programs to cease to run. So we can protect that by doing a couple of things, and that is we need to make sure that anytime we get data from the user that we are getting reasonable data, as well as making sure that we handle if invalid data is entered in. So what I'm going to do now is go ahead and change this program to allow us to capture or expect that data and handle it appropriately. So what we're going to do is we're going to put a block around this single line here, because this is the problematic line. This is the line that may fail if invalid data is entered, and we want to trap for it and handle it. And Java, along with many other languages, has what is called an exception handling ability. What you can do is you can kind of wrap this line of code with what is called an exception block. And the way we do that is by, I'll make some space here. So I'm going to put a try in a curly brace block and wrap it around the line that is the line that may or may not work depending on the validation. So we're basically saying, look, we want to try the next line or try the statements that are inside this block. And if for some reason something happens in there, we want to catch the exception and do something special with it. And the way we would catch blocks is we say, look, we're expecting that if the user may do something wrong, and in our case, we expect that we might get something called a number format exception. And there's plenty of exceptions out there that you can trap for. Number format exception just happens to be the exception that occurs whenever Java can't parse a string into a number. So I'm going to go ahead and put in number format exception. And the way this works is it will attempt to try line 9. And if for some reason it can't parse line 9, it'll go into this exception block. And that's where we can actually do our own handling. For example, we can say, the option pane, show message dialog. You entered an invalid entry. Please try again. Okay. The other thing I'm going to have to do here is, again, as we know with variables, any variables that are declared inside of a block are only visible or in scope in that block. So this integer here needs to be declared up here. And then down here I simply will just access that variable. If I didn't do that, then basically if I tried to access that variable age outside of that exception block, that try block, it wouldn't know what that variable was because it would be out of scope. So I'm simply declaring that variable so it's available for the entire method. Okay. One other thing I'll keep in mind here is that you'll notice that little red squiggly line here, that basically tells me that age hasn't been initialized because I haven't set it. It's a possibility. Java's smart enough to know there's a possibility here that age may not get a value if in fact an exception occurs, then age may not have gotten a value. So we need to take that line of code as well and put that in that same block. So these two blocks are going to be in the try block, and Java is going to try to run those two lines. If for some reason the number from an exception occurs in any one of those two lines, lines 10 or line 11, then it will fall into the exception block or the catch block. And let's watch and see how that works. If I run it, there's the program. I type in 43. We'll see it works correctly this time. It does, and sure enough, I get your age is 43. I will run it again. This time, I will enter in invalid data. And if I do this, if my exception block is correct, then what should happen is it should fall into the catch block and give me my error message that I've entered invalid data. You have entered an invalid entry, please try again. And you'll notice that I did not get my prompt here, because as soon as this line failed, it jumped immediately into this exception block and basically skipped over the remaining lines in that exception block. That's exactly what we want to happen. So now I run that to the end. You'll notice that the program behaved correctly. I didn't get my exception block anymore because we have now captured or controlled access to that block, and therefore the program will not give you a runtime error because we're actually what is called handling that error. So this is fine, but problem is that we want to take this a step further, and that is we want to provide a way for the user to retry. We don't want the program to end. We want to give them the ability to retry, and that's where we'll take advantage of the next structure, which is our looping structure, to provide a validation loop. So here I have that same program. I've added a couple constants here because I want to do simple validation and utilize that. So obviously if someone's putting in an age variable, then we need to do reasonable validation for that as well. So an age probably is more likely that someone is not going to be, a maximum age would be 150, the minimum age someone can be is 0. Okay, so we'll put those validations. And what I want the program, how I want the program to behave is I want the user to enter in their age, and if by chance they enter it in invalid data, then I want them to retry that operation. So here's what we're going to do. We're going to take this logic and simply wrap this with a do while loop. Right, so do while loop here. And I'm going to go ahead and indent a little bit. All right, and what I want to happen is I want the user to continuously be asked to enter their age until they actually give me a valid age. So basically, while the age is less than min, or age is greater than max, then I want them to go back to this line and reprompt them. So if they entered, if we get the exception block, then we want them to have to re-enter their age. We want to give the error message, and then we also want to give them a nice error message. So I'm going to take this over here, put this there. So if for some reason they give us, if the catch block happens, let's go ahead and make it min age equal, make age equal min age minus 1. All right. And all right, so now if for some reason the exception block, we're going to pretend as though the user gave us an invalid age. And then if for some reason they gave us a valid number that we can format, we're just going to double check and make sure it's within the right range. I'm going to take the same branch here and do that. Okay, so walking through what I've done here. So now I've got this entire block here to ask for the user's name. I'm sorry, their age. All right. If for some reason we can't parse the age, it's going to fall into the exception block, and we're simply going to pretend as though the user gave us an invalid age, which would be min age, which in this case is 0 minus 1. So we're going to pretend as though the user gave us a -1 as a person's age. That's a convenient way of being able to handle exceptions gracefully. In addition, we can then once this exception block is done, it will fall down into this branch here. And then basically, if we check to make sure that if for some reason the age they gave us is less than min age or it's greater than the max age, then we need to just tell them that they gave us an invalid age and ask them to retry the operation. Then we just double check that. So if it's out of range, then it's just going to keep prompting them to enter the age until such fact that they actually gave us a good age, and then we'll actually print it out. So let's go ahead and run it. All right, so this time I'll put in a big number there, and I get my block here. It basically came through here and said, okay, I didn't get the exception because it was something that could be formatted, but the number was too large, so therefore I got my error message. And then it's going to make it, the loop's going to go back and ask me to do it again. This time I'll enter another invalid number, and then we'll get that same error message. It's going to continuously ask me to enter the age correctly until I give them a valid age, at which point it will fall out of the loop and go on to the rest of the program and print out, in this case, just print out the age is 34. Let's try to get the same thing. This time I'm going to run it and enter in a value that cannot be parsed. What that's going to do is it's going to cause the exception block, the catch block, to be executed, and it's going to execute line 16. And it's just simply going to set the age variable to something out of range, which is the minimum age, in this case 0 minus 1, so age will be set to a -1. And then on line 19, it will cause the error message to be presented, just like as if the user had given us a valid number, but it happened to be out of range. So convenient way of being able to do a single validation to handle both invalid data that can't be parsed as well as range validation that's out of range. And there you have it. You have a simple program that does simple validation. And what's good about this is that this same logic can be moved into a function, and you can create custom functions that can do this operation for different types of data if you want to go that route. And that's it. Thanks for watching.